Here we have the set of integers modulo 6, and there are two questions about this set. The first one is we need to prove, or we need to figure out whether this is a group with respect to addition modulo 6, and the second question is we have to do the same with multiplication modulo 6, right? So let's consider first A and consider addition. Well, of course, both addition and multiplication are associative and commutative properties. So this is associative, right? That's the first requirement that we need to satisfy. And then the second requirement is the existence of a neutral, and the neutral here is clear, is 0, right? Any element n from this set plus 0 is equal to n modulo 6, of course, right? So 0 is the neutral. And if we want to calculate, well, we want to obtain the inverse of every element. Well, if you pick an element n, the inverse is just 6 minus n, because n plus 6 minus n is just 6, which is 0 modulo 6, right? So this is associative and commutative, right? It's got a neutral element and an inverse. Every element has an inverse, so therefore this is an abelian group. With respect to addition, okay? So we're considering here addition. Now we consider multiplication. Well, again, it's associative and commutative, right? That's out of the question. Associative plus commutative, because so is the multiplication, right? There's a neutral for multiplication, which is 1, right? So if you multiply any element of this set by 1, it's just n modulo 6, right? So there's a neutral, no problem. However, there's no inverse, not for every element, right? The inverse of 0 doesn't exist. Does not exist. That's not the only element. I mean, even if you suppress the 0, because that's normally what you do when you're dealing with multiplication, 0 is problematic. Even if you remove the 0, so you consider a new set, well, let's say G, a new set G, which is this one minus 0, still this is not a group, because there are numbers like 2 which have no inverse. The reason is, in order to find the inverse of 2, we need to find an n such that this is equal to 1 modulo 6. But that's impossible, because this is always an even number and this is always an odd number, and this equality is impossible, right? So 2 does not have an inverse. So again, this does not exist, right? So this is just an abelian monoid. Abelian monoid. Okay, with respect to the product, right? Even if we suppress the 0, it's still an abelian monoid.